Okay, nice on. Hi, good evening, everyone. As Elias mentioned, my name is Yan, and I'm an engineer at Space 8 Games. We are the proud creators of some award-winning games such as Transformers, F-Wars, and Rival Kingdoms. And we also got some really interesting, exciting new games coming to a mobile device near you in the near future. On the back-end side of things, all of our stack runs on AWS, and on a more personal note, I've been using AWS since about 2009. And before joining Space 8 Games, I was working in social networking with a startup based in London called Yubble, where we built a social networking app that's a mixture of Instagram, Twitter, and Facebook. And the Lambda became a very prominent feature of architecture. It wasn't always like that. When I joined the company last year, around April, we had a pretty standard monolithic application where we got a couple of Node.js systems running on EC2 instances. And like many monolithic systems, they look very simple on paper, but as you peel away the covers, you uncover all these hidden complexities and dependencies inside each of those boxes. Because we had, in terms of our traffic, we see a lot of massive 10, 20x spikes in our traffic whenever a popular user is doing some social media campaign. So we tend to run our instances on 20, 30% CPU, which means that we are throwing away 80% of what we are paying for. And because EC2 scale takes, 10, 15 minutes, so in order to have enough headroom when these spikes come, we tend to scale early as well, which means that we also end up paying even more stuff that we don't use. At the time, deployment was taking up to 30 minutes, and it required downtime. And all of this is really was driving me pretty angry inside. You see, one of my favorite speakers, Dan North, once said that the lead time to someone saying thank you is the only reputational metric that matters. And in order to get that well-deserved thank you, we need to first deliver value to people. And to deliver value, we need to ship software. And until our software is shipped, we haven't done anything as far as the users are concerned. So with this in mind, I sat down with the team and we came up with a list of things that we would think as what a good architecture would look like for us. We want deployment to be small, to be fast, to have zero downtime, and we absolutely do not want to do lockstep deployments with the client releases. And we want features to be loosely coupled through messaging, and that they should be deployable independently. This allows different components to evolve at their own pace, and we don't want everything to have to evolve at the same pace as the slowest component in our architecture. And from the ops side of things, we want to be more cost efficient by cutting out all the fat in our AWS bill, and we want to minimize the amount of time we spend just babysitting our infrastructure. We have plenty of technical mess to deal with, and whilst we address those, we also want to continue to deliver visible value and improvements to our users, and we want to do it faster than we've ever done before. All of this is pointing us to a very different style architecture than what we started with. And by November last year, in a very short space of time, we have largely evolved to an event-driven, service-oriented architecture, with Lambda being the centerpiece that glues everything together. At this point, we have over 170 Lambda functions running in production, but we were paying 5% for Lambda what we were paying for EC2 for a comparable amount of compute. More importantly, we are now doing releases to production much, much more frequently. Going from doing 4 to 5 releases a month, we peak at 155 releases in the month of September. What this has also done is, beyond improving our core tech stack, is it also helped improve our communication with the product team. It helped change their minds in terms of what is possible, and the communication is now also different. They come to us with what they actually want to build, rather than the halfway house solution that they think we can deliver within a reasonable amount of time. And from the moment that we decided Lambda is a good fit for what we're trying to do, we had answered quite a few different questions to get to the point where we can be confident and comfortable running Lambda functions in production. How will our CI/CD pipeline look like in this new world? And how are we going to do local development, debugging, and testing? And what about logging, monitoring, and alerting? And by the time we have hundreds of functions running in production, there's a whole bunch of other questions that we now need to answer, because our architecture has now expanded to include many different services that so often depend on each other. In this world, how are we going to do distributed tracing? What about config management and the security? So for the rest of the talk, I'm going to focus on answering these questions and provide you with some idea of the different solutions that you can apply for yourself. But for now, let's have a look at some of the work that we were able to implement with Lambda to give you a more context around those challenges that we're going to be talking about. When I joined the company, the search feature in our app is essentially one big regex query against MongoDB, which, as you can imagine, is not going to scale well. In fact, we're running into performance issues even at the 100,000 user mark, and it was really difficult to do anything beyond rudimentary ranking on the search results. As the first step of our migration process, we make sure that our legacy systems are now publishing events into Kinesis whenever states change, so that we can attach a Lambda function to process them and update a user index in Cloud Search. And we fronted that with an API, creating an API gateway with a Lambda function. A newer version of our client app can use the new search API to find users by first name, last name, and username. And while at the same time, we also proxy the legacy system's search endpoint to point to the new API so that older versions of the client can get the benefits straight away as well. We also didn't have much of an analytics pipeline to speak of. So we went and built one by consuming the same stream of Kinesis events with a Lambda function and streamed them into Google BigQuery. And the first version of this took one developer 2 days to go from the initial discussion to actually running in production. And at the time, our BI guy who's just joined us from Skype actually came to us afterwards and said that, hey guys, well done. Thank you so much, because nothing ever got done this fast at Skype. No offense to anyone from Skype, but it just goes back to the point that we want to optimize for the lead time to someone being able to say thank you for the work that you're doing. As we get more comfortable working with Lambda functions and running them in production, we start to tackle more visible and bigger and complex parts of our application. Like Twitter, we have a timeline feature where you can see posts from the people that you follow. The implementation was pretty complicated and a bit over the top, and it was so difficult to work with, and therefore it was really unreliable and bug-ridden. In fact, so much so that the QA team gave up testing it a long time ago. And since by then, none of the developers were in the company anymore, don't know where they are. So we sat down with the product team to figure out what it is that they want a feature to do, how it's supposed to work, and we built it from the ground up by having Lambda functions consume events from Kinesis whenever you're creating a new post, deleting stuff, whenever you follow or unfollow someone. And these Lambda functions will work out where your posts need to be distributed to by working out who your followers are, and then batch them into groups of, say, 1,000, and publish an SNS message for each batch, which are then handled by another Lambda function who would then add your posts to your followers' feeds that are stored as a sorted set in Redis. We do this via SNS to leverage the retry mechanism you get with SNS and Lambda to avoid repeating the work of figuring out where your posts need to be distributed to, because that can potentially be quite heavy on a database in terms of load. We fronted the Redis feeds with a feed API, and our new version of our client app will use that directly, and we use the same trick of same approach of proxying the existing endpoints to hit a new API so that we deliver value to all client versions as well. And that's typically how we approach migrating to a new service gracefully. Being a social network, we have a feature to suggest you who you should follow. And I kid you not that when I joined the company, that screen used to return the first 30 users from the database by account creation time, which is obviously not useful to anybody apart from that first 30 people that joined the platform. So we improved it by first creating a cron job in CloudWatch that will trigger a Lambda function, and you will run an ad hoc query against BigQuery where all of our analytics data are and work out who the current trending users are in our platform, store them in DynamoDB, and front it with an API and Lambda function. And whenever you follow someone or unfollow someone, those events are processed by Lambda function to update a social graph that's stored in GrapheneDB, which is a hosted version of a Neo4j graph database, so that we can very easily and quickly find second and third degree connections just for you. So those are people that follow your followers or people that are followed by the people that you follow. At the time, we weren't in a position to update our client app, so instead we just proxy the old endpoint to use the results from these two new APIs instead. So that's just some example of work that we were able to implement very quickly with Lambda. There's a lot more where that came from. Actually, some of my colleagues are sitting here right at the front, so if you're interested in finding out about what we do, feel free to pick those guys as well. So let's... All that plus all the things we're going to be talking about, less than 6 months. So just to show you how much you can actually get done once you alleviate yourself in all the complexities and responsibility of managing your own infrastructure. So in terms of getting production ready, the number one thing I would say is that you should use a deployment framework, and there's plenty out there in the market. The one we used was called serverless. I think we heard from Ryan earlier, where he's got a Flask that's got a serverless logo on that. So we use them because there's a commercial company behind it. They're well-funded, got full-time people working on the framework. And from what I could see, there was also a lot of momentum and enthusiasm from the community to help improve the platform and drive where it needs to be. Recently, they also added the multi-cloud support, even though I don't buy into the notion that multi-cloud support is going to make cloud migration projects easy. But I do believe there's a lot of value in being able to use the same tools as you move from cloud provider to provider. It's the same way that we find a lot of value with Terraform. There's also Apex, which I've heard a lot of good stuff about, and that's the framework that we're currently using at SpaceApe. You have Cloudia, Zapper, Sparta. A few of them support different languages. I think Sparta supports Go, which is not natively supported by Lambda. As you start working on your Lambda functions, you're developing them, you need to start being able to test them pretty quickly as well. And the best book that I've read on testing is this one by Steve Freeman and Ned Price, where it talks about the different levels of testing, from your unit tests where you test some business logic, to integration tests where you want to make sure that your code is going to work against code that you don't control and you can't change. And since Lambda function is just a function that Amazon calls on your behalf with some event and context argument based on how it's being triggered, there's no reason why you can't call your function yourself with a stubbed context and event object. The key thing to remember is that the purpose of integration testing is to test your integration points, so you should run your function against the real downstream systems and not mocks. Which brings us to acceptance testing. So at this point, you would have deployed your Lambda function, and now you can run tests against the system end-to-end to make sure that the whole thing is working. As you go up this triangle, you're trying to improve the speed of the feedback loop for developers, but going downwards is all about increasing the confidence you have that what you've done once deployed is going to work in the wild. And one of the key things to learn from this book is that you shouldn't mock types you can't change, because, and I quote, "We find that tests that mock external libraries often need to be complex to get the code into the right state. The mess in this test is telling us that the design is not right, but instead of fixing the problem by improving the code, we have to carry the extra complexity in both the code and the test. And we have to be sure that the behavior we stub or mock matches what the external library will actually do. Even if we get it right once, we have to make sure that the tests remain valid when we upgrade the libraries." And I think the same principles apply here for services, especially in this increasingly service-centric world that we now live in, that you really shouldn't be mocking services that you don't control. And for acceptance test, they should exercise the system end-to-end without calling directly its internal code. An end-to-end test interacts with the system only from the outside through its interfaces. So when it came time to run acceptance tests for our newly created search API, we will create the test cases by talking to the legacy system via HTTP, the same way that our client apps would do. And we validate that the whole system is working as expected by calling the search API to validate that a new user on a platform is now searchable by first name, last name, and username. As for CI and CD pipelines, there's a tendency or temptation to leave them too much later on in your development cycle. But since they are a mechanism for saving you time and to help prevent human error, I think there's a strong argument for you to consider them much earlier on, potentially even at the start of a project. And Steve and Nat had this to say about testing end-to-end, that we prefer to have the end-to-end test exercise both the system and the process by which it is built and deployed. This sounds a lot of effort, because it is, but it has to be done repeatedly anyway during the software's lifetime. At this point, you're probably thinking to yourself, well, I know exactly what to do. I'm going to have a Jenkins build config that's going to do my deployment and then run my acceptance test end-to-end in one fell sweep, which is great. But one of the things that's been me time and again in my career is all these magic scripts that only lives on the CI box. They're not source control anywhere. So inevitably, at some point, someone, maybe yourself, would make a change, break the build, and now you have no source control to tell you who changed it, when, why, and more importantly, what was the old version so that I can roll back. So for that reason, we insist that every project will have a very simple build script, which should provide a thin layer on top of what serverless framework and NPM is giving us already. And all it does is help us orchestrate the different types of testing as well as deployment with a one-line command that we can put into Jenkins build config. And because it's just a script, it means that we can run it both locally as well as on the CI box. I think people call them pipeline as code nowadays, but I'm not quite sure. I'm not quite up to date with the lingos. As for continuous delivery and the deployment, the way we've had this thing set up is such that the production environment runs in a separate AWS account. And from the moment that code is pushed into Bitbucket, we will trigger a unit test, integration test, do a deployment to the integration environment, and then run acceptance test. And for release branches, we will also then automatically promote it to the test environment, where QA can do their stuff, and then to the staging environment, which is a production-like environment. But to production, it's a manual process where we just have to press a button. The key thing is that we are always in a position to be able to release things when it suits us. And we typically don't deploy on Fridays because there's strengths involved in the afternoon, so obvious reasons. Once your code is running in production, you're going to need to be able to monitor them. Whenever your Lambda function writes to standard out, Lambda service will capture those and then asynchronously ship them off to CloudWatch logs, so it doesn't add to your function duration. And you also get additional information, such as the UTC timestamp, or if it's API gateway then request, then you also get a unique request ID. But what it doesn't do is to make sure that the logs are easily searchable. And this problem is compounded when you have more and more and more functions. And it's a common problem people have in the microservices world. And the general consensus there is to have your logs in one centralized place and make sure that they can be easily searched, which just basically says ELK, which is what everybody uses nowadays. And in the CloudWatch logs, you can pick a log group, you can subscribe it to a Lambda function, so that whenever you get new log messages, your function gets called, and you can then ship them off to your ELK stack. But every time you create a new Lambda function, there's a new log group that you will need to subscribe, and you don't want to have a manual process for someone to have to remember whenever you create a new function, now go to CloudWatch, your logs, and subscribe it to your log shipping function. And what you can do in that case is to create a new event in the CloudWatch events and match it against the create log group API call, so that every time a new log group is created, you can then call a Lambda function and programmatically subscribe that log group to your log shipping function. So now you've got all your logs in one place. It's nice, it's searchable, it's great, but at times you're still going to need a bit more help. For instance, whenever you post the content, your followers get them in their feed, but a lot of different things have to happen to make that feature work. And suppose one of your users, or maybe your QA engineer, comes to you and says that, well, I posted something, but my followers didn't get them, or one of my followers didn't get them. The problem can lie in a number of different places, because the system, the data flows through many different parts. Even though you've got your logs, but they're all over the place, and there's no easy way to string them together to get a chronological view of everything that happened in order from the moment that you post something to it ending up in your followers' feed. And what you need in this case would be correlation IDs that flows through all of the things that happen and the logs message that relate to them. So things such as the original request ID that created the post, And because the system flows through APIs, through Kinesis events and SNS messages, it means that your correlation IDs also need to flow through all of those things. And the way we approached it was to roll our own client libraries by wrapping around our favorite HTTP client as well as the AWS SDK client for Kinesis and SNS, so that we can capture the correlation IDs from inbound, and then we pass them outward as well. This is a common problem people have. So Amazon announced the X-Ray at the last re:Invent. I haven't had a chance to play with it. It's still in preview, and as far as I know, it doesn't support Lambda functions yet. Is that right? Is that more or less?
I'd say we're previewing already. Just kind of a private beta for them. But once, as soon as it comes out, you will support both.
Do you guys hear that? Great news. So Heiter from AWS just said that you're going to get it pretty soon, support for Lambda, which is music to my ears. In terms of monitoring, now that we don't have servers, it means that we don't have anywhere to install monitoring agents, which is how we normally monitor stuff. And instead, now we have to solely rely on the metrics we get from CloudWatch. And a couple of guys, such as Datadog, they have announced support for monitoring Lambda, but most of the time I find that they just use the same metrics you get from CloudWatch logs, but give you a better looking dashboard. The things that the IO pipes guys is doing is slightly different. They give you a wrapper library to wrap your function code around so that they can intercept the start and end and capture interesting stats and send it to their own backend, which also happen to be written all in Lambda. And this approach of wrapping your function code so that you can address cross-cutting concerns is the same approach that we took for all of our Lambda functions. Internally, we've got a Power Tools library which does that, give you all the sort of common set of things that we want from API functions, Kinesis event processors, and SNS, and so on. The hesitation I have for using something like OwlPipe is that it's another thing that I don't control that can add latency to my function calls and potentially cause them to timeout. And especially for user APIs, I need to be very conscious of doing anything that's going to add to my latency, because that's going to impact my user experience. Another thing that we are very used to doing with the instant virtual machines is to send metrics and logs in the background so that they don't add latency to our HTTP handlers. In Lambda, well, you kind of have to do everything during the function invocation. There's no such a thing as idle time you can use to do send logs and whatnot, which means you're now forced to make some uncomfortable trade-offs between having lots of useful metrics and latency. I found a number of different ways to mitigate this problem, and the best one I found is how Datadog is doing to support custom metrics, and it's an approach that you can easily apply for yourself as well. Essentially, you track your logs, your metrics, as a specially formatted log message, so that those get captured by Lambda, shipped to CloudWatch logs asynchronously without any overhead to your latency. And now you have a Lambda function that's processing them and shipping them to Outstack, and you can use the same guy to identify those metrics and send them to CloudWatch instead. Now you're trading off liveliness for your metrics for the lack of latency overhead. And it's not the right approach for everything. And I would recommend that you mix and match different approaches based on the situation. So for user-facing APIs where latency is critical, maybe do this. But for other things, that's processing background tasks, Kinesis, for example, where your latency is less critical, send your metrics and logs during the function invocation. And once you've got all your metrics in one place, set up nice dashboards, put them on monitors, hang them around the office, and set up alarms, hook up Opsgenie, ping them, whatnot, and don't forget to add tracking for application-level metrics. So, for example, where we are serving content to our user, one interesting metric, application-level metric, would be the number of posts that we are serving, as opposed to the number of API calls that's hitting that particular endpoint. Now, CloudWatch is good. It's decent, it's cost-effective, and in some cases, the only way for us to get metrics out of Amazon systems, such as Kinesis and DynamoDB. But it's got plenty of limitations. The UI is very basic. There's not as many customization options as its competitors. Metrics are only granular down to the minute, and it doesn't have advanced features such as anomaly detection that you find in Stackdriver, for example. And the big reason for not using CloudWatch for me is that you really don't want your monitoring system to go down at the same time as the system that is monitoring, which has happened to me quite a few times during Amazon outages, where EC2 goes down at the same time as CloudWatch or S3. So I have no visibility to what's happening to my users and how it's affecting my system. Good, we're ahead of time. So config management, whatever the approach you use, the goal is to make sure that you can easily and quickly propagate config changes to all of your functions. Nowadays, when you create a new Lambda function, you can set environment variables and even have KMS encrypt them for you. And this was the approach that we started off with, using environment variables in serverless framework because it wasn't available in Lambda at the time. But we quickly found that as an approach, it didn't scale as we added more and more functions. So trying to update, say, MongoDB connection string across 50 different Lambda functions, well, that's someone's full-time job for 2 days. So you don't want that. Instead, we invested a lot of time, well, not a lot of time and effort, but some time and effort into moving to a centralized config service, which can be just as simple as a key value store. Considered console, SCD, but in the end, we decided to just roll our own with API Gateway, Lambda, and DynamoDB because it's an order of magnitude cheaper. And it also means that we have less infrastructure that we have to manage and run. And since pretty much all of our functions need some config value of some kind, we wrote a robust client library that supports caching and periodically refreshing from the config service so that we can easily propagate changes such as the MongoDB connection string change across all of our functions quickly without restarting and redeploying. And when you've got sensitive data such as credentials or connection strings, you want to make sure that they are always encrypted, both in flight as well as at rest. And you want to have role-based access to those data. And the way we approached it was to use KMS, the Key Management Service. Yes, I got it right. Whereby a developer will encrypt, say, your connection string or credentials using KMS, which has got role-based access, and store them in the config API in its encrypted form. And when a Lambda function starts up, it's going to ask the config API for config values, which is transmitted over HTTPS, and also in the encrypted form. And then it's permission to use KMS to decrypt them. So it's only ever in the unencrypted form in memory when it's running, as well as in your developer's head or whatever he's written it down on the notepad. We secured our config API and all of our internal APIs using API keys that you can create in API Gateway. But that's not great. That's not role-based. But API Gateway does support the use of IAM roles for securing your APIs. That's the direction we were moving towards, but never got around to doing it, unfortunately. I also saw other people use serverless framework plugins to do this, but they didn't satisfy my requirement for propagating changes across all my functions, so we didn't end up going with them. Okay, to close out, just a few more miscellaneous tips for managing Lambda functions in production. Because Lambda functions can time out, typically that means you get 500 on your API gateway. That's not a very meaningful HTTP status code for timeouts. So what you can do is to match the timeout message to a 504 instead, which is a gateway timeout, and that's a much more meaningful way to communicate that there's a timeout rather than just miscellaneous server error. And one hard lesson we learned was that do not, and I repeat, do not use 128 meg memory setting for production. Because the amount of CPU resource you get on your Lambda function is proportional to the memory setting you choose for the function, and we found that with 128 meg, there are cases where sounds like the VM never got enough CPU time to actually load out and run our code. So despite repeatedly calling the function, it just does nothing and just times out all the way. And this happens for 4 hours straight. And the reason for that, we will talk about it soon. And it's not just us. I wrote a blog post on this a while back, and from the comments from other people, this is a problem that a lot of people have run into in production, and they've all reached the same conclusion as us, that you should just avoid using 128 meg setting for production altogether. Anything that to keep in mind about Lambda is that when they're idle, i.e. not being called for, say, I think 5-10 minutes, it gets unloaded from the host VM, which means the next time it's called, there's a noticeable penalty for cold starting the function to load it, unzip the package, and run it and whatnot. And one of the ways you can sort of mitigate this is by having a cron job in CloudWatch events to call a Lambda function and just ping your, user-facing APIs and keep them warm. And you can also integrate the health check logic as well in your ping handler. But even then, we found in practice our functions are recycled at most 4 hours, sometimes less than that. And this theory is backed by some research done by the IOPipes guys that they also found that cold starts happen with a few exceptions, 4 hours from the time that the host VM was created. So the moral of the story is that you should avoid making hard assumptions about the lifetime of your function. That being said, Lambda does reuse existing functions if it's already been created as a way for optimization, and you should take advantage of that. So if you've got local state, don't initialize them every single time. Instead, keep them around so that you can avoid doing expensive work every single invocation, such as connecting to MongoDB or loading some cache data or whatnot. But you should use them only for optimization and not count on them to be there from invocation to invocation. And we also found that there's limitations on the maximum package size you can upload each time, and there's also a count-wide limit of 75 gig, which may sound a lot, but believe me, with a serverless, everything is so easy to deploy, so quick. With a small team of 6 people, we managed to rack up something like 20 gig of deployment packages in 3 months. By which point, we kind of have to do something, otherwise you're going to hit a limit in another 3 months. Even though most of our packages is only 2 meg, but we're doing it so frequently, some of our functions in development would have hundreds of deployments within a space of a couple of days. So we took a leaf out of Netflix's book where they've got Janitor Monkey. I wrote a Janitor Lambda function. And also created that logo too. So all this guy is doing is going around running periodically to find old versions of a Lambda function that are no longer referenced by an alias, and deletes them. So with that, we went all the way back down to less than a gig of actual deployment packages that we need to keep around. There's an upper limit of 5 minutes for execution time. So if you want to do anything longer than that, write them as a recursive function so that if you need to process a whole list of S3 files, just pass the token around for the next core so that when you run the second time, when you recurse, it will just continue from where it left off from the previous invocation. And where you're using Kinesis with Lambda together, and chances are you probably would do a lot of them, keep in mind how retry works with Lambda and Kinesis. So if your function errors, Lambda is going to call your function again with the same batch until it succeeds, which in practice means that you need to really think about how you're going to handle partial failures and whether or not your functions should be allowed to error at all. So here, because you are essentially trading off liveliness of your event processing for consistency and guarantee that something's worked, and take as an example for our feeds. Suppose one of my followers, in writing to his feed, something happened and it continued to fail. Do we want to stop the rest of our system, all the other users, from getting their feed? Or should we just say, all right, we tried our best, we move on? And the most cases that we can think of, just do your best and then move on is the right default approach. But you can do something a bit smarter. Well, we talked about you can use the local state for optimization. You can also use them for clever retries as well. So you allow your function to fail, but you recall which records failed the first time around. So when it gets retried, you only retry the ones that fail up to a maximum number of attempts. And after that, dump them into SQS or just write them into logs somewhere. And then allow your stream processing to continue on. Maybe even set up alarms on your SQS dead letter in queue so that someone can look at them and do some manual intervention. And one of the things that's currently lacking is the support for SQS as an ingress source for Lambda functions. So I did a bit of proof of concept work for an architecture built entirely with Lambda functions that allows you to poll SQS for tasks, process them, and also scale elastically based on the size of your backlog. It's too much to go into right now, but there's a link at the bottom of the slide, which I'll share later on. So feel free to go and have a look if interested. Another thing that we found, because we use Kinesis an awful lot, is that Kinesis only, every shard in Kinesis stream only supports up to 5 reads per second, and that every Lambda function that you subscribe to that stream would have one instance of it running for each shard, or polling independently on some interval, which means that by the time you have 5 or 6, and this is just our empirical evidence, Lambda functions all subscribing to the same stream, you start to see read throughput exceptions on your dashboard. Typically, this error is not really visible to you because it's all just happening to the Lambda service trying to pull data from your stream. But it does mean that you can have the cases where a particular function, a shard, would keep trying to get data but keep failing, so that you have unpredictable spikes in your iterator age, or the amount of read latency, so the amount of time from the event going into Kinesis to your function being able to pick it up and process it, which can affect the liveliness of your stream processing for that particular function. And something is worth keeping in mind, not the reason to not use Kinesis in Lambda. And one of the ways that we've been advised by the AWS support on how to mitigate this is by having smaller number of essentially distributor functions that would subscribe to Lambda, the stream, get the records, and then distribute it workloads to other Lambda functions. But remember we talked about how you have to think about partial failures? In that case, that consideration is going to get so much worse. So even though it's a potential solution, it's not one that I would go down lightly. Maybe you should consider is Kinesis the right choice for this particular work you're doing, or maybe having Kinesis events be more granular or having them duplicated. There are different ways to consider with different trade-offs, but I'll leave it to the reader to think about. For now, thank you very much for listening. Most of the things I've talked about are written down as a blog as well, so go read them if you like. I think we've got 10 minutes for questions.
Wow. Wow. That was absolutely amazing. I'm absolutely exhausted. It felt like 12 rounds with Lewis Hamilton around the Abu Dhabi track. Absolutely exhausting, but I wouldn't miss it for a million years. So absolutely brilliant. Thank you so much. Any questions, please? Oh, come on.
That's Monday.
I noticed you said at the start that you're one of the first people who you had to develop a new feature, got the feature into production in about 2 days.
Yep.
Is that still the case now that you've got all this complexity, or has things slowed down a bit?
So the question was, at the start, we were able to get our first version of our analysis pipeline into production in 2 days. Did we slow down as we get more and more things? I don't remember. Do you guys remember? I think it depends on the feature, the size of the feature. We did end up working on bigger piece of feature. So rewriting the timeline, for example, that took, I think, about 2 weeks, 2 people to work on it. And also we had a very big feature to implement comments as well, which we didn't have at all in the platform, and that required a lot of rewrites. So I think that took a couple of sprints. At the same time, the suggestion thing where we find training users and then we put them into graph database and all of that, that was done really quickly. The training, the whole working out who the training users are, I did it as a side project, like in my evening, in one night. And the next day I went back to the product team, we worked out, we refined the formula we used to put in time decays and all that, so that people that just been followed recently counts more than people that follow you 6 hours ago. That was done literally within a few hours of my time. So it depends on the size of the feature. With the complexities, most of those things, the way we approach it was so that you can easily be adapted and used by someone else working on different function. So I don't think there's too much slowdown. maybe the slowdown comes more from the additional complexities of what we're trying to do, rather than, well, now we have to think about more things. Does that answer your question? Okay.
Okay, we've got time for one. Okay, two more questions. Hold on.
Similar to microservices, where you get
Yep.
too many microservices there
Yep.
running, how do you plan to deal with the functions that you now have that will grow and nobody cares to maintain them?
So the question was similar to microservices. You can have thousands of services running, all doing some special thing that no one has the oversight to understand all of them. I think that's a problem that we're going to have eventually. And at least until November, I was able to have an oversight to understand what everything is doing, not to the implementation details so much, but to know what its responsibilities are and how it's going to dissect the different features that we have. But at the same time, there's only 6 of us. We typically work in pairs on different features. So a whole block of architecture would be responsible to support a particular feature. So those guys are the domain experts for those areas. I think as we grow, that's going to be the model that we're going to have to go down anyway. You can't have one person knowing. Like Netflix doesn't have one person to understand all the thousands of services they have. If you see in diagrams how they interact with each other, you just see, well, it's art. But yeah, so it's a problem that we're going to have eventually. Unfortunately, we never got a chance to have that.
Final question.
What languages are you using, and are there any operational concerns and constraints, any differences between them that you noticed for the Lambdas? So Node, JS, Java, Python, etc.
Okay, so the question was, what language were we using, and what operational concerns that we have with different languages? So we were using Node.js. An interesting thing to note is that we all came from other different backgrounds. I think Elias mentioned that I'm a polyglot software architect. All it means is that I program in a lot of different languages, C#, F#, Scala now, but I never touched Node.js. So this job was the first time I've ever written any Node.js code. And I was quite afraid of Node.js at the start because, people keep telling me JavaScript doesn't scale with complexity. And the funny thing I found for that is because Lambda functions are all so small, you're constrained on the amount of complexity that you can put in each one of them, which means you have an upper limit on how complex each component can be, and therefore, even JavaScript, Node.js didn't scare me anymore. I actually came to quite enjoy writing stuff in Node.js for that matter. In terms of operational concerns for specific languages, I'm not sure because we've only used Node.js for Lambda function. And now I'm actually working in Scala as well. I'm starting to experiment with Scala and SBT. There's a template for that in the serverless framework as well. So I guess we'll find out. Maybe I'll tell you in 6 months' time.
Brilliant. Thank you so much. Round of applause for Yan. And so Yan, you'll be around later on, yeah? So yeah, if you've got any other questions, yeah, Yan will be around downstairs while, when we're networking. So thanks very much for that. Our next speaker is Niraj from AWS, and while he's setting up,